According to the National Electrical Code, it is not permitted to connect two separate circuits to a single two-pole circuit breaker. Each circuit must be protected by its own individual breaker or fuse. Therefore, using one leg on each pole of a two-pole breaker is not approved. It is also not approved to use individual single-pole breakers as a double-pole breaker, even if their handles are mechanically connected by a tie. Double-pole breakers are designed to provide separate protection for both the phase and neutral conductors of a circuit. Using single-pole breakers as double-pole can lead to potential hazards, such as arc faults or neutral return problems. Each circuit must have its own dedicated single-pole circuit breaker or fuse. For multiple circuits that need to be interrupted simultaneously, a multi-pole breaker such as a two-pole or three-pole breaker must be used. The National Electrical Code establishes guidelines for electrical installations to ensure safety and proper functioning. Circuit breakers are crucial safety devices designed to protect electrical circuits from overcurrents, which can result from short circuits, overloads, or ground faults. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to equipment and potential fire hazards. There are different types of circuit breakers, each designed for specific applications and voltage levels. Single-pole breakers are commonly used for 120-volt circuits, while double-pole breakers are used for 240-volt circuits. Three-pole breakers are typically used for three-phase power systems. The amperage rating of a circuit breaker indicates the maximum current it can carry without tripping. Selecting the correct amperage rating for a circuit breaker is essential to ensure proper protection. If the amperage rating is too low, the breaker may trip unnecessarily, while if it's too high, it may not provide adequate protection against overcurrents. The code specifies requirements for circuit breaker installations, including proper wiring methods, grounding, and enclosure types. Circuit breakers must be installed in readily accessible locations and properly labeled to indicate the circuits they protect. Regular inspections and maintenance of circuit breakers are essential to ensure their proper functioning. Breakers should be tested periodically to verify that they trip correctly under overcurrent conditions. Any damaged or faulty circuit breakers should be replaced immediately to prevent potential hazards. It is crucial to understand the code requirements for circuit breaker installations and to follow them carefully to ensure electrical safety. The information provided here is for general guidance only, and it is always recommended to consult a qualified electrician for specific electrical work. Now let's delve into more specifics about circuit breakers and their applications. Firstly, understanding the different types of circuit breakers is essential for proper electrical system design and safety. Single-pole circuit breakers, as mentioned before, are typically used for 120-volt circuits. These breakers protect a single hot wire and a neutral wire. They are commonly found in residential applications for lighting circuits, receptacle circuits, and small appliance circuits. Secondly, double-pole circuit breakers are designed for 240-volt circuits. These breakers protect two hot wires and a neutral wire, providing a balanced voltage supply. They are often used for larger appliances like electric ranges, water heaters, and air conditioners. Thirdly, three-pole circuit breakers are used in three-phase power systems, which are common in commercial and industrial settings. These breakers protect three hot wires, providing a balanced three-phase voltage supply. They are used for equipment like motors, HVAC systems, and industrial machinery. The trip curve of a circuit breaker describes its response to overcurrents. Different types of breakers have different trip curves depending on the application. Inverse time breakers trip faster as the overcurrent increases. These breakers are commonly used for general-purpose circuits where short duration overloads are expected. Instantaneous trip breakers trip almost immediately when an overcurrent occurs. These breakers are used for sensitive electronic equipment that requires rapid protection. Dual-element breakers have both inverse time and instantaneous trip characteristics. These breakers provide both overload and short-circuit protection. The interrupting rating of a circuit breaker indicates the maximum fault current it can safely interrupt without failing. It is crucial to select a breaker with an interrupting rating that is high enough for the potential fault currents at the installation location. If the interrupting rating is too low, the breaker may fail during a fault, leading to equipment damage and potential hazard. The code specifies requirements for the interrupting rating of circuit breakers based on the available fault currents at the service entrance. Ground fault circuit interrupters, or GFCIs, are specialized circuit breakers designed to protect against ground faults. A ground fault occurs when current leaks from a hot wire to ground. GFCIs detect these small current leaks and quickly trip the circuit, preventing electric shock. GFCIs are required in wet locations like bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are designed to protect against arc faults. An arc fault is an unintentional electrical discharge between two or more conductors. FSIs detect these arc faults and trip the circuit, preventing fires. FSIs are required in bedroom circuits and other areas where arc faults are more likely to occur. Surge protective devices, or SPDs, protect against voltage surges caused by lightning strikes or other electrical disturbances. SPD divert the surge current to ground, preventing damage to sensitive electronic equipment. SPD are recommended for all electrical systems, especially those with valuable electronic equipment. Now let's discuss the importance of proper circuit breaker installation and maintenance. Firstly, circuit breakers must be installed in readily accessible locations. This allows for easy access for inspection, testing, and replacement. Secondly, circuit breakers must be properly labeled to indicate the circuits they protect. This helps to quickly identify the correct breaker during troubleshooting or maintenance. Thirdly, circuit breakers should be tested periodically to verify that they trip correctly under overcurrent conditions. This can be done using a circuit breaker tester. Fourthly, any damaged or faulty circuit breakers should be replaced immediately. Damaged breakers may not provide adequate protection and can pose a safety hazard. Fifthly, circuit breakers should be kept clean and free of debris. Dirt and dust can interfere with the breaker's operation. Finally, circuit breaker panels should be properly grounded. This helps to protect against electrical shock. The code provides detailed requirements for grounding electrical systems. Understanding these requirements is essential for ensuring electrical safety. Proper grounding helps to prevent voltage buildup and provides a path for fault current to flow back to the source, tripping the circuit breaker. Now let's address the specific questions about tying two circuits to a two-pole breaker and using single-pole breakers as double-pole breakers. According to the code, it is not permitted to connect two separate circuits to a single two-pole circuit breaker. Each circuit must be protected by its own individual breaker or fuse. This is because each circuit is designed to carry a specific amount of current, and connecting two circuits to a single breaker can overload the breaker and create a fire hazard. It is also not approved to use individual single-pole breakers as a double-pole breaker, even if their handles are mechanically connected by a tie. Double-pole breakers are designed to provide separate protection for both the phase and neutral conductors of a circuit. Using single-pole breakers as double-pole can lead to potential hazards such as arc faults or neutral return problems. In summary, each circuit must have its own dedicated single-pole circuit breaker or fuse. For multiple circuits that need to be interrupted simultaneously, a multi-pole breaker, such as a two-pole or three-pole breaker, must be used. Multi-pole breakers provide a common trip mechanism, ensuring that all circuits are interrupted simultaneously in the event of an overcurrent. This helps to prevent equipment damage and electrical shock. When selecting a circuit breaker, it is important to consider the following factors. Firstly, the voltage and amperage rating of the circuit. Secondly, the type of load being protected. Thirdly, the interrupting rating of the breaker. Fourthly, the trip curve of the breaker. Fifthly, the presence of ground fault or arc faults. Sixthly, the environmental conditions. By considering these factors, you can select the appropriate circuit breaker for your application and ensure electrical safety. Now let's discuss some common electrical hazards and how to prevent them. Firstly, electrical shock can occur when a person comes into contact with a live electrical conductor. To prevent electrical shock, always de-energize circuits before working on them. Use insulated tools and equipment, and wear personal protective equipment such as rubber gloves and safety glasses. Secondly, electrical fires can occur when electrical circuits are overloaded or when there are loose connections. To prevent electrical fires, ensure that circuits are properly sized for the load. Use properly rated circuit breakers and fuses, and inspect electrical wiring regularly for damage or loose connections. Thirdly, arc faults can occur when there is an unintentional electrical discharge between two or more conductors. To prevent arc faults, use of size in bedroom circuits and other areas where arc faults are more likely to occur. Fourthly, ground faults can occur when current leaks from a hot wire to ground. To prevent ground faults, use GFCIs in wet locations and ensure that electrical systems are properly grounded. Fifthly, voltage surges can damage sensitive electronic equipment. To prevent voltage surges, use SPD to protect against voltage surges caused by lightning strikes or other electrical disturbances. By taking these precautions, you can help to prevent electrical hazards and ensure electrical safety. Always remember to consult a qualified electrician for any electrical work. Electrical work can be dangerous, and it is important to have the proper training and experience to do it safely. A qualified electrician can assess your electrical needs, recommend the appropriate equipment, and install it correctly. They can also troubleshoot electrical problems and make repairs. By hiring a qualified electrician, you can ensure that your electrical system is safe and reliable. The code is constantly evolving to address new technologies and safety concerns. It is important to stay up to date on the latest code requirements to ensure that your electrical system meets the current standards. The National Fire Protection Association, or NFPA, publishes the code, and it is available for purchase online or through authorized distributors. Many states and local jurisdictions adopt the code, with or without modifications. It is important to check with your local authorities to determine the specific code requirements in your area. The code is a complex document, and it can be difficult to understand without proper training. There are many resources available to help you learn about the code, including online courses, seminars, and workshops. You can also consult with a qualified electrician or electrical engineer for assistance. The goal of the code is to protect people and property from electrical hazards. By following the code requirements, you can help to ensure that your electrical system is safe and reliable.